Okay, so let me see now. For those persons who did the test 4, I said that you get the mark script at 11, and then yeah, so we could look at that a little later in the class. But I want to just begin by looking at our content for today. But I think we stopped at 7.3. We were looking at system of linear equations in 2 variables, but we looked at the graphical method for solving. And with those questions, I think we were using the intercepts. So let me just quickly look at I think Ms. Nan asks about 9 and 11. So let me see. So question 9, it had y equals x plus 5, and then y equals negative x plus 3. Okay. So when we want to graph linear equations, well, there are a couple of ways we could do it, but we looked at point plotting. We looked at using the X and Y intercepts, and then we look at the slope intercept. But with those equations there, probably the quickest thing would be to do the X, Y intercept. So basically what we want to do is find 2 points on the line. And when we were doing it last time, we saw where graphing was not very accurate at times. And so that's why today we're going to move on to look at more accurate ways to solve system of linear equations. But if you were using the graphical method, for the first one, y equals x plus 5, you're going to find the value of x when y is 0. So if y is equal to 0, then you say 0 equals x plus 5. So you could rewrite that as x plus 5 equals 0. So x is equal to negative 5. So the point you would plot for that is negative 5 and 0. And then if x is 0, you would say y equals 0 plus 5. So y would be equal to 5. So x is 0. So 0, 5 would be a second point. So you'd go on your graph and you'd plot after you label to drop your axis, you would plot negative 5, 0, and then you would plot 0, 5, and you join them together to make the line for this first equation, which is y equals x plus 5. Now, for the second equation, we do the same thing. So come over here. Let's go all the way up. Y equals negative x plus 3. So you could let y be 0. So if y is equal to 0, so 0 equals negative x plus 3. So if you want, you could move the x over. X equals 3. All right. So the point there would be, we made y 0. So if x is 3, you would say then the point is 3, 0. That's one of the points on the line. So we made y 0. Now let's make x 0. So if you make x 0, then you would say y equals 0 plus 3. So y is equal to 3. So x, we made x 0. So the second point then would be 0, 3. That's when x is 0, y is 3. So for this other line, you would plot the point 3, 0 and 0, 3, drawing them together. And where this line meets the other line would be the solution for those two systems of equations. Okay. So Ms. Fernanda, you follow that?
Yeah, I got that. Okay.
Yeah. So
Yeah.
that's how we'll deal with that. So the next one would be basically the same sort of thing. You would have to rewrite the equations and let x be 0, then y be 0, find the two points on the line and do likewise with the second one, and then we got them. Okay, so for today, we'll look at some other methods for solving the system of linear equations.
Hello, Mr. Allen.
Good morning. Yes, ma'am.
I wanted you to go over one from the next exercise.
Which page is this in?
At section 7.2.
So which question?
That would be question 21 and 29.
21. Okay. So 21 says, let me see, do that here. Y equals 2x plus 3. Y equals 2x plus 3. So it says you have to graph each linear function using the slope and Y-intercept. Okay. So, and which one? And the other one you said was 29. 29. Okay, y equals negative 3 quarter x plus 4. Y equals negative 3 quarter x plus 4. Okay, so in your book, let me see which page that is on. Trying to find the page. Okay. So in your book, you will, on page 386, you will see the formula y equals mx plus b. All right, and that is the slope-intercept form of an equation. And in that formula or equation, the m represents the slope and the b represents the intercept. Okay, so and that is the y-intercept. So if you look on page 387, it tells you graphing y equal mx plus b using the slope and y-intercept. So it says it's 3 steps they give you. Plot the point containing the y-intercept on the y-axis. And then to obtain the second point using the slope. So in this first one here, the y-intercept is 3. So basically, if I don't have a graph here, but I'll just do a quick sketch. So this is your x-axis, this is your y-axis. So if you want to graph this first one here, your y-intercept is 3. So you're going to go on the y-axis, and wherever 3 is, you're going to mark a point there. So I'm going to assume that's 3. Okay, so this number here tells you where the line passes through the y-axis. And then this number in front of the x is the slope. And the slope tells you how steep the line is. So for every, it's the rise over run. So every 2 up you move, 2 by itself is equal to 2 over 1. So your rise is 2 and your run is 1. So when you see, you're going to start at 3 and you're going to move up 2, which is going to take you to 5, 3, 4, 5, then you're going to move across 1. If you go up.
That's what I was doing, but I wasn't getting the same plot as the book, so it was confusing me because they have, I was trying to figure out if they did it in reverse.
Mm-hmm.
They went down 2 and across 1.
Yeah, you could do that too, because remember it's rise over, so you could go down 2 and move across 1, because yeah, because basically you could go up 2, across 1, down 2, to the left 1.
So it doesn't matter which direction, I could go either way once it isn't a negative number.
Well, you see this rise over run? Every 2 that you move up, you're going to move across 1. So if you move down, so this, if you move down 2, then you have to move to the left 1. If you move up 2, you have to move to the right 1.
Okay.
To keep the slope the same. If you want to go down 2, then you have to move to the left 1. And if you're going up 2, then you move to the right 1. So it would be on the, so if you go down 2 and what you might end up somewhere here, it would still be in line with the
slope.
Yeah, the slope would still be the same. All
Okay.
right. And the good thing with that sometimes is if you could get more points, it makes your line more accurate. Because as you see, if you just get 2 points and the 2 points are close together, sometimes your line will not be too accurate, because the more points you get on the line, the more accurate you can actually draw the line. So that's how that could be done. All right. And then the second one here. Now this one, it says the y-intercept is 4. So you're going to mark 4 on your graph, where 4 is. And then this says negative, which means that the line is going to be going downwards instead of up, like this first one. First one, the slope is positive, so it would be moving upward. When the slope is negative, you're going to be moving downwards. And so that 3 over 4 means you're going to go down 3 and move across 4. So you're going to move down 3. Anytime it's negative, you move down. So you're going to count 4 spaces. So you're going to count 3 places down. So your rise will be downwards instead of upwards. And then you're going to move 4 places to the right. Okay. So if you want to go up instead, then you'd have to move 4 places to the left. to keep the slope. But if you follow what this is saying, you go down 3, move to the right 4. If you want to get more points, you could go up 3, but you have to move to the left 4. You do the opposite. Okay?
Okay, I get it. My only issue was that I didn't know that they
You
were.
could do it both ways.
Yeah.
Okay. All right. Okay, so now on page 396 of your book, those same equations we were looking at just now, where we were trying to solve them graphically, we can solve them. There are 2 other ways that are mentioned in your book. One is by the substitution method, okay? And the other one is by the addition, or what they call elimination method. So we're going to start off with the substitution method, which is explained on page 396. So it says this method involves converting the system to one equation in one variable. Okay, and so the steps are shown there, 5 steps. It says solve either of the equations for one variable in terms of the other. Okay, and if one of the equations is already in this form, then you can skip that step. So we'll look at an example after this. Substitute the expression found in step 1 into the other equation. This will result in an equation in one variable. Then you're going to solve the equation containing the one variable. And once you get that answer, you're going to back substitute the value found in step 3 into the equation from step 1. And then you could simplify that to find the remaining variable. And then you're going to check to see if it works for both. Okay? So that's on page 396, this explanation, this 5-step. So we have an example here. It says solve by the substitution method. So here we have 2 equations, y equal minus x minus 1, and 4x minus 3y is equal to 24. Now, last week when we looked at this, we were using the graphical method to solve it. But today we're going to be using the substitution method. Now, you will see here where it says solve either of the equations for one variable in terms of the other. If one of the equations is already in this form, you can skip this step. So this equation here is telling you that y is equal to something. So this equation is already stating the value for y. This one is not telling you the value for any of the variables. It's saying 4x minus 3y equals 24. So you can skip step 1 because it's already written in a form that's telling you what one of the variables is equal to. It's telling you that y is equal. So if you have an equation that says y is equal to something or x is equal to something, that's already in the form that you could use to substitute into the other equation. All right. Now you'll see in this study tip, it says in step 1, you can choose which variable to isolate in which equation. If possible, solve for a variable whose coefficient is 1 or -1 to avoid working with fractions. So for example, if you had chosen to use this equation instead, you could have said 4x equals 24 plus 3y. And then you would say x is equal to 24 divided by 4 plus 3y divided by 4. So x would be equal to 6 plus 3/4 y. So you end up with a fraction. And that's what they're suggesting, that if you have a coefficient that is just 1 or -1, it's best to use that equation that has that in it rather than to use one with a number higher than 1 or lower than -1, because oftentimes you're going to end up with a fraction, which makes the calculation a little bit more complicated. So you could avoid doing that if possible, because there are sometimes when you cannot, because all the coefficients will be either greater than 1 or less than -1. So because this equation is already written in the form y equals -x minus 1, you could go straight ahead and substitute this value for y into the second equation. So it was y equal -x minus 1. And so you're going to take out the y out of the second equation and put this value for y in its place. So what we did then here is the second equation, we're going to put 4x minus 3. And we know that y is equal to -x minus 1. So we're going to take the y out and put the -x minus 1 in its place, equals 24. So that way now, we only have one variable to work with, which is x. So we can solve for x. And once we finish solving for x, then we could use the value that we get for x to find what y is. So now that we have this with x only, we could go to step 3. Okay, 4x minus 3 times -x minus 1 equals 24. -3 times -x gives me a positive 3x. -3 times -1 gives a positive 3. So now 4x plus 3x is 7x, plus 3 is 24. 7x is equal to 24 minus 3, which gives me 21. So x is equal to 3 because you're going to divide 21 by 7, and that's how you get x equal 3. So now, because we were able to substitute the value for y in this, we end up with one variable. We solve for that variable. Now, since we know x is equal to 3, we can now substitute that 3 into basically any of the equations to find what y is. All right. So what they did, they went back to the first equation, which was y equals -x minus 1. So we're going to, since we got that x is 3, we're going to put the 3 in place of x. So y equals -3 minus 1, y equals -4. So the answers would be x is equal to 3 and y is equal to -4. And that's the solution. Now, basically what this is saying to you is that if you were to draw a graph for these two equations, the point at which they meet would be 3, -4. So let's say 3 is here and -4 is there. The two lines would meet at that point, 3, -4. Okay, so you could check to make sure it works for both. So what you would do, you would say, well, the first one says y equals -x minus 1, y equals -x minus 1. And the second one is 4x minus 3, y equals 24. 4x minus 3, y equals 24. All right, so x is 3, y equals -4. So you would, for the first one, you would say, okay, y is -4, so you put -4 equals x is 3, so that's -3 minus 1. Okay, -3 minus 1 is -4, so -4 equals -4, so that's true. And then for the second one, we're going to do now 4 times x, that's 4 times 3, minus 3 times y is -4, equals 24. 4 3s are 12. And minus 3 times -4 gives me plus 12, equals 24. 24 equals 24. And that's true. Okay, so it works for both. So when you check, make sure you check both equations to break, because sometimes if you can get a wrong answer that works for one equation but doesn't work for the other. So you check both to see if it is true. All right, so I want you to try this one. Okay, so you're going to solve by substitution method. This one is similar to what we just did. They already tell you what y is. So you're going to substitute the value for y into the second equation, solve for x, and then once you get the value for x, then you could back substitute into the first equation to get y. I'll give you a couple minutes to work on that. Right, today's okay, Ms. Nairn, you want to tell me what you did so far?
Miss Allen, you could skip me. I just rejoined and I kind of lost.
Yeah, that's how you could find your way by let's going through it together.
Okay. So,
You see what they have here? Y equals 3x minus 7. So you already told that y is equal to some value. So you could substitute that value for y into the second one. So if you do that, what's going to happen?
Okay, so it's going to be 5x minus 2 open bracket 3x minus y close bracket.
No, not minus y. 3x minus.
Oh, sorry, 3x minus 7 close bracket equals 8. So then it will be 5x minus 6x minus 14.
Hold on now. Hold on. Minus 2 times minus 7.
Oh, negative 14? No, 14?
Okay, plus 14.
Equals 8. So then we would say that'll be -1x.
Okay, negative x.
Plus 14 equals 8. And then we would say negative x is equal to 8 minus 14. So then negative x is equal to 6.
8 minus 14. What is 8
Oh,
minus
that's
14?
negative. Oh, okay. 8 minus 14. That's negative.
That's negative 6.
And so we'll say, yeah, so that's it.
So if negative x is equal to negative 6, what is x?
Negative 6.
If negative x is equal to negative 6. So we're looking now for what is
Oh, so then we'll say negative 6 divided into -1 equal to 6.
right. So x itself would be equal to 6.
Right.
All right. So x would be equal to negative 6 over negative 1. X equals 6. All right. So you know x is equal to 6. So how can you find y?
Okay, so to find y,
You know what y is. The first equation told you what y is. What did the first equation say?
3x minus 7. So then it'll
Yeah.
be 3 times 6 minus 7. So that'll be 18 minus 7 is equal to 11.
So you weren't that lost after all. Okay. So x equals 6 and y equals 11. So if you were to draw a graph for those two equations, they would meet at the point 6, 11. Okay. 11. All right. So that's how you'd solve that one. Y equals 6, x equals 6 and y equals 11. Okay. So that's your substitution method. Now I have this other one here, but it is not written in the form that this one was written. They tell you what y is, but in this case, you are not told what y is, or what x is. You don't have to get y, you could get y or x. So Miss Fernanda, tell me what you could do with this one to start things off. Fernanda, you there?
I'm here. Okay.
Yeah.
Oh Lord. So we'll say 3x plus, oh, first we have to change, I guess, the x minus y equals 3, because it's not.
It's not stated in terms of x or y.
Yeah.
So you could rewrite it either in terms of x or in terms of y. Which one would be easier to do?
I guess rewriting it in terms of y, we can move the x over. No, in terms of y, terms of x, so we can make the y positive.
Okay, so right. So because if you write in terms of y, you're gonna end up with a negative y there. So it's best to change it over. So x minus y equals 3 would be written as x equals what?
3 minus y or y. I mean 3 plus y or y.
3 plus y or y plus 3. It doesn't matter. Okay. So now that you have done that, what would be the next step?
So now we can say 3 open bracket 3 plus y, close bracket,
Mm-hmm.
plus 2y equals -1.
Okay. All right. Go ahead. You could go ahead. Give you a couple minutes to work that.
Okay.
Finish it off. Okay, Ms. La Rochelle, tell me what you did.
I have 3x plus 2y equals -1.
Mm-hmm. So when you're going to substitute the x equals 3 plus y into the first one.
Yeah, so you'll put it in brackets.
3 plus y
Close
plus
bracket.
2y
Y equals
plus,
-1.
mm-hmm,
So that's 9 plus 3y plus 2y equals -1.
mm-hmm,
5y equals -1 minus 9. 5y equals -10.
mm-hmm,
Y equals -10 divided by 5 equals -2.
mm-hmm. Okay. So now we know y is -2. How are we going to find x?
For x, we'll say x equals 3 plus -2. X equals 1.
Okay, so x equals 1, y equals -2. And you could always check and see if it works for them. So let's check and see. So the first one is 3 times 1 plus 2 times y equals -1. So that's 3 plus -4 equals -1. -1 equals -1. So that's true. And then for the second one, we have x, that's 1 minus -2 equals 3. 1 minus it, same as 1 plus 2 equals 3. 3 equals 3. That's also true. Okay, so it works for both. So we know that our answer is correct. So you can always check your answer and know if it's correct. Okay, so that's your substitution method. So sometimes it's straightforward where you are given one of the equations in terms of a variable. but sometimes you have to rewrite or rearrange. Now, in some cases, you may have both of these with a coefficient that's not 1 or -1, so you may end up with a fraction, but the process is the same. But as much as possible, we try to use a variable where the coefficient is either 1 or -1. Now, the other method is the addition, they call it, or elimination method. All right. So it says here, it's also known as elimination method. The name addition specifically tells us that the elimination of a variable is accomplished by adding two equations. So we have to add the two equations. All right. So on page 3, I think it's 398 of your book. 398 is where they discuss the addition method. And then on page 399, you will see the steps that are listed out here, 6 steps. All right. They want you to write the equation in this form. So the variables will be on one side and a constant on the other side. Okay. Then you may have to multiply either equation or both by some non-zero number in order to get either the x coefficients or the y coefficients to add up to 0. And once you do that, then you can add the two equations together. And when you add them, you end up eliminating either the x or the y. Then you could solve for the remaining variable and then do your back substitution into one of the equations to get the second variable. And then you check. So we have one example here, example 5, where you're given these two equations. So this addition method is useful when you don't have any of the coefficients equal to 1 or -1. So you have 3x plus 2y equals 48, 9x minus 8y equals -24. So with this addition method, you're going to add the two equations together. But if you add these two together, you're going to get 9 and 3 is 12. And then you're going to get, if you add 2 plus 8y, -8y, you're going to get -6y. So you're not going to end up eliminating anything here if you add these together. All right. So what you have to do is see if you could find a number that you could multiply one of the equations by or both so that the coefficient of these two are the same or the coefficient of these two are the same. So either the x's have the same coefficient or the y's have the same coefficient. Okay, so step 1 says rewrite both equations in the form ax plus by equals c. Now, they're already in that form in this case. So you don't have to rewrite them. They're already in this form that they ask you to write it in for the addition method. Okay, so the variables are on the left and the constant is on the right. So now, step 2 now is where you have to do that multiplication. So what they did here is they multiplied by -3. They multiply the first equation by -3. That way, you end up with a -9 in front of this one. And when you add -9 to +9, you're going to eliminate the x's. All right. But when you multiply by -3 to get this to be -9, you have to make sure multiply the entire equation. So it's going to be -3 times 3x give you -9x. -3 times 2y gives you -6y. And -3 times 48 gives you -144. Okay. And then of course, you don't need to do anything to the bottom equation because it already has this 9x, which would cancel out with this -9x up top. So once you add the two equations together now, this negative 9x plus positive 9 is going to eliminate x. You're going to get 0x, which is 0. Negative 6 plus negative 8 gives you negative 14y. And then negative 144 plus negative 24 gives, excuse me, gives negative 168. So now you have eliminated the x. Sorry. So you can now find y by dividing 168, negative 168 by negative 14. So when you do that division, sorry about that. When you do that division, you're going to get y is equal to 12. Okay, so that's step 4. We solve for the variable that we did not eliminate. So now that y is equal to 12, we can now substitute the value that we have for y into any of the two equations. They did it for the first one. So you put the 12 in place of y. So you say 3x plus 2 times y equals 48. So 3x plus 24 equals 48. 3x would be equal to 48 minus 24, which is 24. So x would be equal to 24 divided by 3, which is 8. Okay, and then you could check your answer with the two equations to see if it works for both. I'm not going to check it, but generally you should check to ensure that it works for both. I just want to focus on the method for the addition or elimination method. Okay, so the main thing now is to see if you could find a number to multiply both equations by. Well, you don't have to multiply both. Sometimes you just need to multiply one. Sometimes you may need to multiply both. And sometimes you may not need to do any multiplications because you may have it already given to you in a form where you could eliminate. Okay, but in this case, they use -3 and to do the elimination. Can you see some other number that you could multiply by to in this? Because you didn't have to use -3. What else could we have used to eliminate? We could have tried to eliminate the y. What could we have multiplied those equations by to eliminate the y?
4.
4. Okay, you could have multiplied the top one by 4. So if you multiply by 4, you get 12x plus 8y, and then 4 times 48, whatever that result would be here. So that way, if you have 8y here and a -8y there, that would cancel out the y. So you get, add these two together, 12 plus 9 gives you 21x. And then you add these two together and then you work out what x is. Then you substitute that into the equation to find the value for y. Okay, so that's your elimination or addition method. All right, I wanted to try this one. So we may have different routes to eliminate. So not all of you are going to necessarily get the same number to multiply by, but whatever you use, once you're consistent, you should get the same result. I want to try this one. Okay, Ms. Fernanda. Are you there? Ms. Fernanda. Mr. Rochelle,
Yes.
what answer you got?
For Y, I have 1.5.
Mm-hmm.
And I was working X right now.
Okay, let me hear what you did.
I multiplied the bottom equation by 2 to cancel out the 4x.
You multiply by what?
I multiplied the bottom equation by 2 to cancel out the 4x.
Now, if you multiply by 2, you're going to get 4x at the bottom also. And 4 plus 4 is 8. You understand me?
But are we multiplying it to cancel so they can be the same so it could cancel out?
No, they can't be the same. They have to be opposites.
Oh.
So
Okay, let me.
what should you multiply by? Not 2, but
Multiply by 4.
no, you could multiply by 2, but not positive 2.
-2.
Yeah, because you want to eliminate, you want the 2 to have opposite signs. You see? So if you multiply by 2, you won't touch the top first one. It'll be 4x plus 5y equals 3. And then you're going to, if you multiply times -2, you're going to get -4x minus 6y equals 14. Now that they have opposite signs, you could now eliminate that. Okay. And then let me double check something here. 4 plus 5y equals 3. And then you multiply them by 2. So 2 times, -2 times this will give you negative. Okay, so this should be a positive 6.
And -14.
With a -14. Okay, so we multiply by, we're multiplying by -2. So -6, sorry, -2 times -3 will give you a positive 6, and -2 times 7 will give you a -17. So now you're going to add that to get, that's 11y equals, that's -11. Yeah. So therefore, y would be equal to what?
-1.
-1. So now that we know that y is equal to -1, where do we go from there?
You substitute the y in the top equation.
Okay, so you can say 4x plus 5 times -1 equals 3. Okay. So 4x I guess you could say -5 equals 3. So 4x would be equal to 3 plus 5. 4x equals 8. So x would be equal to 8 over 4. X equals 2. So x equals 2. So what I wrote there, sorry. X equals 2. Y equals -1. We check our answer. So you'd say 4 times 2 plus 5 times -1 equals 3. 4 twos are 8. 5 times -1 is -5. And 8 minus 5 equals 3. 3 equals 3. So that's true for the first one. And then the second one, you have 2 times 2 minus 3 times -1 equals 7. 2 twos are 4. And -3 times -1 is a +3. 4 plus 3 is 7. 7 equals 7. That's true. So it works for both. Yeah. Okay. So, okay, let's look at this next one. Miss Nan, what you need to do with this before we can do substitution? Not I mean the addition method or elimination method.
You need to bring the signs over.
The variables. Okay.
Variables over.
So how would you write the first one?
So the first one would be 3x plus 4y equals 2.
The second one would be
5y plus
well,
2.
we want to keep the x's together and the y's together.
Oh, okay. Okay, so it'll be negative. So would it be 2x plus 5y is equal to -1.
Okay. All right. So that's the start. So you could go ahead and finish it off. Give you a couple minutes to finish that one.
Hi, my internet dropped for a minute.
Oh, Miss Fernanda, yeah, I called you a couple times. Okay.
But I'm looking at this, I'm lost because I see you had to rearrange it and I see you have 3x plus y. We don't, is it 4y or?
Oh,
Because I was
yeah,
lost now. I was trying to
yeah,
figure out something.
yeah. Sorry, it's 4y.
Okay.
Good, very good observation. Yeah. Yeah. There. Okay, Miss Fernanda, you with us?
Okay, let me see.
Mhm.
Um, I don't, okay. What I times it by -3, so I can cancel out the top line, the 3x. So I said -3 times 2 would give me the -6x. And then,
You multiply the top by -3, you said?
yeah.
Mm-hmm. So you
So
get,
I would have to
you
work
get-
out the whole top line with the
yeah, so
negative.
that would be, well, -3 times 3 will give you 9, -9x.
Oh, I thought I was just focusing on the bottom when I cancel, just to cancel it out. Okay, so I was focusing on the bottom one. I said -3 times times 2.
Oh, you did the bottom one by -3.
Yeah, so I'm supposed to work out the top first? I thought
No,
the top was last.
it doesn't really matter, you know. What you really need to do is find a number that would multiply either the top or the bottom so that either the x's are the same or the y's are the same. Well, I shouldn't say the same, but they are opposites.
Mm-hmm.
But in this case, it seemed like you have to multiply both the top and the bottom because there's no number you could multiply 2 by to get 3 or 4 by to get 5 or 5 by to get 4. So you're gonna have to multiply the top by some number and the bottom by some number, so you get either the x's or the y's to cancel out each other. So what two numbers could you use?
3 and 2.
You could use 3 and 2, but where you'd use 3 for the top or for the bottom?
Okay, so I can use 3 for the bottom
Mm-hmm.
and 2 for the top.
Okay. Now you know that if you use positive for both, you're gonna end up with,
Negative, yeah.
so you can't use positive for both. One have to be negative, one have to be positive because you want them to cancel out when you're finished.
Mm-hmm.
So you could use 2. Okay, so you could say times -2 for the top and times +3 for the bottom. So if you multiply the top by -2, what you're going to get?
But I want, okay, I'll get -6.
Negative 6x.
And then for the y, I would get negative
No.
8.
Negative 8.
And then
8y
equals negative 4.
equals negative 4. Okay. So I'll just take out this plus and leave it as negative 8. All right. And for the bottom,
For the bottom, I got negative 6x.
well,
minus
it will, you multiply them by 3 now.
Yeah.
3 times 2x. What is 3 times 2?
So that's 6x.
6x, and then 3 times 5,
Is 15y. 15y
15y, and 3
equal
times like
the 3.
to
Negative.
minus 3. Okay. All right, so now you can add, and because you have a negative, let me put this here to show. So this negative 6 plus 6 would cancel out the x's. So now you have negative 8 plus 15 gives you what?
7.
So that's
Y.
7y. And then minus 4 plus minus 3 is?
Negative 1.
No.
Hold on, minus 4. Oh, yeah, I didn't change it. Sorry. 4. 4 plus minus 3 is negative 1.
No, just negative 4.
Just positive 1. Yeah. Negative
Negative
4
4
plus
plus negative 3.
it's negative 7.
Negative 7. So that means y is equal to
Negative 1.
negative 1. So if y is equal to negative 1, we're going to find x.
We'll have to substitute it into the top one. So we'll say
Okay.
3 times the negative 1.
Well, 3 times x, because we don't know what x is. We don't know what y is.
Oh, yeah, sorry. 3x plus.
Well,
4.
I was using this one here. This one
Yeah,
that is
the top one. Okay.
Mhm.
3x plus 4.
Well,
sorry. Plus
right here.
3x equals 2 minus 4 times negative 1.
Okay, minus 4.
So we have to use the original one to substitute, not the one that we.
It's best to do that because, yeah, you could use any of them, in fact. But when you said the top one, I thought you were referring to this. But you could use the bottom one, or you could use the ones that you converted. All right. So 3x equals 2 minus 4 times negative 1. Okay, so 3x equals 2, and 4 times negative 1 is?
Negative 4. I mean positive 4. So
Sorry,
4.
that's really negative 4 times negative 1.
4
That's plus 4. So 3x equals 6. X would be equal to 6
divided by
over 3. X equals 2.
No.
So x equals 2 and y equals negative 1. And we could check our answer to see if it works for both. Thank you. Ms. Nairn, what numbers do you use to multiply?
I use, for the top one, I use +2. For the bottom one, I use -3.
+2, -3. Okay. +2 and -3. Okay, so all right, no problem. Yeah, that works out. Miss La Rochelle, what did you use?
I use the same numbers.
Same. Okay then. All right. Thank you. All right, we could have used 5 at the top, 5 4s are 20, and -4 at the bottom. -4 times 5 would be -20. Of course, you would have to multiply this by the 5 and that by the 4 as well. So you didn't have to focus on the X. You could have eliminated the Y by multiplying by 5 on -4 or -5 on 4 straight across. But you'll get the same result. Okay, so that's it for the elimination method and the substitution method. You'll get a few to practice for homework. And so that would end our look at this section, which is 7.3. And we're going to move on now to a portion of 7.6. So we were looking at graphing linear equations, solving system of linear equations using graphs, and then we also solved the system of linear equations using the addition and the substitution method. Now, in the same way, we have certain principles about straight line graphs that we could use to help us to plot them. Last week, we were looking at using the slope and the intercept. We have some principles that apply to quadratic equations as well. So for the remainder of the time, that's what we're going to be looking at. So the method that we used initially was what we call the point plotting method. And so when we talk about point plotting, basically we get some points that are given to us for the x-axis, and we substitute those points, those values, into the equation that's given to you and work out what the y coordinate should be. And then we plot that and join them together to make a, in this case, what is called a parabola. So if you look at this equation that you're given, it says y equals x squared plus 4x plus 8. And so when we're using the point plotting method, we draw up a table, what we call this a table of values. Some people call it table of values. All right. And you don't have to set it up like this, but that's one way to do it. You put the x squared in one column, the 4x in this case in the next column, and the plus 8 in the next column. And so you work out each of them separately, then you added it up together to get the final result for y. So if you have 5, -5, x as x, then that would be 5 times 5, -5 times -5 is 25. And then 4 times -5 would be -20, and then plus 8. Okay, so when you add 25 plus -20, you get +5. 5 and 8 is 13. Okay, so you put 13 there. And you continue doing the same thing. If you want, you could just do all the squares one time. -4 squared is 16. -3 squared is 9. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. Then 4 times -4 would give -16. -3 times 4 times -3 is -12. 4 times that gives you -8. That's -4. That's 4 times 0 is 0. 4 ones are 4. Then you, of course, you just put +8, +8, +8, +8, +8, +8. And then you just add them up. Okay, 16 on that gives you 0. 0 plus 8 is 8. And 9, and that gives you -3. -3, that gives you 5. That gives you 4. Then what's this? 1 minus, that's -3. -3 plus that gives me 5. Then 0 plus 0 plus 8 is 8. 8 and that gives me 13. All right. So now with the point plotting method now, we get the value for X that's given to you. You're told what to use. You work out using the equation, the value for Y, and then you plot the points. So the first point would be -5, 13. Now this graph, because they have large values for the Y, they can't use the same scale for the X and the Y axis. So this X axis, let me see, 1, 2, 3, 4. Every 5 units equal 1. That's -1, -2, -3, -4. So -5 would be right here. -5. And then 13. So they're going up. Let's see now. That's 5 units. And that's, let me see, 1, 2. That's 10. So that's every 2 is equal to 1. So they'll go here. 10 is a little difficult to see this, but I guess this is 10. So this 2 make 11, another 2 make 12, another 2 make 13. So they plotted that first point right here. And the next point was -4, 8. So -4, and then you go up, and that this is where 8 should be. And then the next one is -3, 5. So that -3, 5. I think I could see the dot here where that is. And the next one was -2, 4, right here. Then -1, 5 is here. Then 0, 8. Okay. 0, 8. Okay. And then the next one is 1, 13, which is right up here. And so what they did after plotting those 7 points is to join them together to form what is called a smooth curve, which gives you the parabola. You're not going to use a ruler to join these. No ruler to be used. It's to be drawn freehand, but you try to do it as smooth as you can to make a curve. Okay? To show the equation for the line y equals equals x squared plus 4x plus 8. So that's your point plotting method. We did that not last class, in the class before that, but I just wanted to review that before we look at some of the properties of quadratic equations that you could use to help you to draw the graph without doing the table of values. This is a sure way, but you need to get at least 7 points to get a sense of how the curve will run. And usually we try to make sure to get at least the point where it's lowest and 3 points to the left or right of that to ensure that we see the pattern for the graph. Okay, so on page 429 of your book, they review what is a quadratic function. Okay, so this is the form. Sometimes it's written like this when we're talking about a function. When we're talking about an equation, it's written y equals function of x is equal to, and this format is the same for both of these, just a difference in the terminology at the beginning. Okay, a, b, and c are real numbers, and a cannot be 0, and the power for x is 2. The highest power for x is 2. All right, now if you don't have this 2 here, if it's 1, then you end up with a linear equation, which will give you a straight line. But once your power is, you have the second power, then you're going to end up with a parabola. The graph of any quadratic function is called a parabola. So that parabola is a curve, and you have 2 examples shown here, and the one we just looked at is also a parabola. So all quadratic equations will produce a parabola once graphed. So if you got a quadratic equation to draw the graph of and you don't get a parabola, then you know you did something wrong with your calculation. So they say that the vertex of the parabola is the lowest or the highest point on the graph. So sometimes the graph may look like this, where this one says it opens upward. So this is your vertex, which is your lowest point. And if it opens downward, then your vertex is your highest point. Okay? The line that passes exactly through the middle is called your axis of symmetry. So you could have an axis of symmetry for both of them, both the one that opened upward and the one that opened downward. Now, you will see here, they tell you that it opens downwards when the coefficient of A is less than 0, and it opens upward when the coefficient of A is greater than 0. So the coefficient of X is greater than 0. Okay, so when we say the coefficient of X is greater than 0, what does that tell you about the coefficient? What kind of number that would be if it's greater than 0? Ms. La Rochelle, what type of numbers are greater than 0?
Natural numbers?
Yeah, but what kind of sign they have?
Positive?
Positive, right. And then when the coefficient of X is less than 0, Miss Nan, what type of numbers are those? Miss Nan, are you with us? No? Miss Fernanda?
Pardon?
What type of numbers have that are less than 0?
That's
What sign do they have? The numbers that are less than 0?
negative.
Negative. Okay. So what this is telling us is that if the coefficient of X squared is less than 0, which means it's negative, the parabola would look like this. It's going to open downwards. If the coefficient of X squared is greater than 0, that means it's positive, then the parabola will open upwards. It will look something like this. Okay? So those are some pointers that will help you if you want to sketch a parabola. You can look at the equation and decide whether it's going to open upward or downward based on the value of the coefficient of X squared. Now, we mentioned about the vertex of a parabola. The vertex, we said, is either the lowest point or the highest point. And if you remember the formula for solving a quadratic equation, in that formula, you would see this variable, and this is the denominator, and this is the first term. So if you remember that formula, that will help you to remember this this little formula here, because this negative b is the first part of the quadratic formula for quadratic equation, and this 2a is the denominator. So what they're saying is that the x-coordinate of the vertex, whose equation is y equal ax squared plus bx plus c, occurs when x is equal to negative b over 2a. The y-coordinate is found by substituting the x-coordinate into the parabola's equation and evaluating y. So let's look at this, page 430. All right. So in 430, they are saying to you that there are several points. There are some points that are helpful when graphing quadratic equation. You can use the point plotting method, which we did here, but you can also use some other features about the quadratic equation to help you to draw a graph of them. And so first, you can know whether it opened upward or downward based on the coefficient of x squared. Then you can find the vertex by using this formula. Okay, so use this formula, and once you find the x coordinate, then you can find the y. Then you can also find the x-intercept. Okay, and from that, you can get 1 point on the curve. And then here they are saying that you could find the y-intercept also, and then you could plot these points to draw a smooth curve. So please note here what it says, although not every parabola have x-intercepts, but in those cases, we might have to use a point plotting method, but we're going to look at a few now that have. So we get this equation, example 6, page 630. So you're told that y is equal to x squared minus 2x minus 3. Okay, the first step, determine, does this parabola open upward or downward? If you look at this, the coefficient of x squared is 1, which is positive. So it means that it's going to open upwards, so it will look something like this. It's going to open upward. So once that x squared coefficient is positive, you get an idea of how your graph will look. If it was negative some number or negative x squared, then it would open the other way around. All right, so it says here, determine how the parabola opens. Since a is the coefficient of x squared and a is equal to 1 in this case, then the parabola opens upward. So it will look something like this. Now to find the vertex, we're going to use the formula x equal negative b over 2a. So b is the coefficient of x, which is negative 2, so minus negative 2. And then a is the coefficient of x squared. A is equal to 1, b is equal to negative 3, and c is equal to negative 3. So a is equal to 1, so put 2 times 1. So negative 2, so minus negative 2 gives you a positive 2, and 2 times 1 is 2. 2 divided by 2 is 1. So the x coordinate for the vertex is 1. And so to find the y coordinate, you're going to substitute the x into the equation, which is this equation here, to find y. So since x is 1, you're going to put 1 in place of x. So y equals 1 squared minus 2 times 1 minus 3. 1 squared is 1. Minus 2 times 1 gives you minus 2. So that should end up being 1 minus 2 minus 3. Okay, so minus 1. 1 minus 2 is minus 1. Minus 1 minus 3 is minus 4. So we got 1 here for x. And then when we plug it into the equation, we get negative 4. So the vertex is at negative 4. So right away, if you were to, this is 1, negative 4. So that's 1, negative 4 would be somewhere around here. So it means that the lowest point of this graph is going to be at 1, negative 4. So it's going to go down, come back around at that point. And because we know it opens upward, we know it should look something like this. So it's just a sketch of what it should roughly look like. Okay. So now, after we find the vertex and we know how it opens, we now need to see if we could find the x-intercept. That means we wanted to find where on the x-axis this graph passes through. Now, like I said, it doesn't have to pass through the x-axis, because if you look at this one we were doing here earlier, this graph does not pass through the x-axis. It's above the x-axis. So not all parabolas pass through the x-axis, but it definitely passes through the y. Okay, but it doesn't, in this case, it doesn't pass through the x. So we could check to see if it does pass through the x, because if it does pass through the x-axis, it would pass in 2 places, and that's 2 points we could use to help us to plot or draw a sketch of the graph. And so what we do It says y equals x squared minus 2x minus 3. So we want to find where it passes through the axes. So we're going to let y be equal to 0. So if y is equal to 0, we're going to solve for x. So we factorize, or we could have used the formula if we wanted to. But in this case, we factorize. And so we factorize that and got x minus 3 times x plus 1. So either x minus 3 is 0 or x plus 1 is 0. So that means either x is 0. Sorry, either x is 3. No, they put x is, no, this should be negative 1. As if x plus 1 is 0, then x would be equal to 0 minus 1. So there should be negative 1. Okay? So either x, well, they have negative 1 here, but they didn't put it here. All right. So the x-intercepts are 3 and negative 1. So basically what this is saying, the line would pass through 3 on the x-axis and negative 1 on the x-axis. So you would have that to use to plot the point, this to plot the point, and this here, and the fact that it opens upwards. So already we have three points. Okay. Now to find the y-intercept, so we found the x-intercept by solving for x. Now the y-intercept, now I said to you, we don't always have to have x, but we definitely have to have a y. It's going to pass through the y at some point. So we let x be 0 to solve for y. So if x is 0, put it 0 into the equation. So you're going to get 0 squared minus 2 times 0 minus 3. And in this case, 0 squared is 0. Negative 2 times that is 0. So that's really 0 minus 3, which is equal to negative 3. So the graph is going to pass through on the y-axis at 0, negative 3. So you would go to your graph, 0, negative 3. Okay, I probably roughly have something here. So that it will pass through here as well. So we have 1, and then these 2, and then the lowest point. And with those 1, 2, 3, 4, we should be able to draw a rough sketch of the graph. So this is not exactly rough. This is a perfect copy of what it should look like. But showing you the points that we found the vertex, which is 1, negative 4. We found the x-intercepts. Okay, that's x is equal to 3, x is equal to negative 1. So we got those 2 points on the x-axis. And then we found the y-intercept, which is negative 3, which means the line passes through the y-axis at negative 3. And so once you get them, you could go ahead and use a pencil and do a sketch of a curve that passes through those points. And you could always extend it a little above, but just try to keep that same pattern rather than trying to narrow it or widen it, as the case may be. Okay, and you're not to use a ruler to draw this, you use freehand. And so that's how you would use the properties of the quadratic equation to plot the graph rather than using the point plotting method. Okay, now you'll find the point plotting method will probably give you more accurate graphs, because here you only have 4 points, whereas you could get as many points as you want on the table of values and plot them. And then even so, in the case of the graph that I was looking at earlier, you would not have x-intercepts to work with. So you would only have the vertex and the point where the line passes through the y-axis, the y-intercept. So with those two, you wouldn't be able to do a proper sketching. So in cases like that where you don't have any x-intercepts, it's probably best to use the table of values to draw the graph. So we're gonna look at this one here. I'll give you a couple minutes to look at it and see if you could work out the vertex, the intercepts, as the X-intercepts and the Y-intercept. And then we'll do a sketch of it. I'll give you a couple minutes to look at that. All right, so Miss Nairn. Miss Nairn?
I'm here.
Okay. So the first thing I need to find out from you is how will this curve look? Is it going to open upwards or downwards?
It's gonna open upwards
Why?
because it's starting at 1 and going up.
Because it's starting at 1?
I mean,
Why?
because yeah, because it's going We're not subtracting, we're adding, so it's gonna go up.
Okay, let me go back a bit. You see those two areas I circled?
Yes.
What do you understand from what that's saying? In particular, right here and right there.
So for the first one, it's saying that the number is greater than 0. And so it went down. And then the next one is saying the number is less than 0.
Okay, so when numbers are greater than 0, what type of numbers are they?
Whole numbers.
No, I'm talking about the sign of the number.
Oh, positive.
Positive numbers. And when numbers are less than 0, they are
negative.
Now, you see this A? Where is this A in the formula, in the equation? What is the A in front of?
X.
No. The A is not in front of X. B is in front of X. The A is in front of what?
The square number.
X squared.
X squared.
Yeah. So the number in front of X squared determines whether the parabola opens up or the parabola opens down. So if the number in front of X squared is positive, it's going to open upwards. If the number in front of X squared is negative, then the parabola is going to open downwards. Okay?
Okay.
So let me go back to the question then. So what number is in front of X squared for this one?
So that'll be 1.
Positive 1 or negative 1?
Positive 1.
Okay, so because it's positive, what's going to happen with this parabola?
It's going to open upward.
Right. Okay. So if I gave you an equation like this, y equals minus 2x squared plus 3x plus 8. What's going to happen with that equation?
It'll open downward.
Why?
Because the number in front of X squared is negative.
Okay. Suppose I say y equals 8 minus x squared.
It'll open downward.
Why?
Because X squared is negative.
Well, the coefficient of x squared is negative. Okay, right. So anytime the number in the coefficient of x squared is negative, the curve will look like this, will open downwards. When it's positive, then it will open upwards. So that's the first thing we have to, we know by looking at the equation, you can tell how the curve is going to look. So right away from this one, we know it's going to open upwards. So the next step now is to work out the vertex. Okay, so we could find the vertex by using the formula minus b over 2a. Okay, so minus b over 2a, in this case, we know that a is equal to 1, b is equal to 6, and c is equal to 5. So if you're looking for minus b over 2a, what would you,
So it'll be minus 6
minus
over
6.
2.1.
2 times 1.
2 times 1, yeah.
So that's going to be minus 6 over 2, which is equal to,
But equals to -3.
okay, -3. Okay. So that's -3. So that just gives you one value. So now we need to find the other value for the vertex. How are we going to find the other value?
So for the other value, that's where we substitute the 1.
We substitute into the equation.
Yes.
So that so we're going to substitute in the equation to get that. Okay. So we substitute in the equation. So how are we going to go about that?
So that would be 1 squared plus.
Well, you said 1 squared?
Yeah, so x squared. Yeah.
Well, why you use 1? Didn't we just work out? We just work out that
oh, that's -3.
Right, we just work out that x is equal to -3.
Okay, sorry. So it's -3 squared.
Okay, so that's -3 squared
plus 6 multiplied by -3 plus 5
plus 5. Okay, so now that would be 3 squared is
9.
-3 squared is 9.
9
plus 6 times
-3 is -18
minus 18 plus 5. Okay, so 9 minus 18 gives you
-9
minus 9 plus 5, which is equal to
-4.
-4. So basically then that is telling you that your lowest point on this graph is going to be where?
-4.
Well, you need 2 points. You work out the x coordinate and now you just work out the y.
So it'll be -3 and -4.
Right. Okay. So you on your graph, then the first thing you can plot is -3, -4. So you go to -3, -4, and so that's going to be your lowest. So I just mark that in red here. -3, -4. So that's your start. So thank you, Ms. Nairn. Let me ask Ms. La Rochelle now. The next thing we want to find is the x coordinates. Ms. La Rochelle, you with us?
Yeah, so you would let y be 0.
No, that's your y. We're trying to find where the line passes through the x-axis. So we have to find the value of x. So
you'll do x squared plus 6x plus 5. Then you will have x plus 5 in open brackets and brackets. Then you'll have x plus 1 equals 0.
Okay, so you have x plus 5, x plus 1, okay, equals 0. All right. So if x is either x plus 5 equals 0, x plus 1 equals 0. So that means x is equal to
-5.
-5, or x equals
-1.
-1. Now, this equation is easy to factorize, but some equations might not be that straightforward, so you may have to use the formula. But if you use the formula, whatever answers you get, then that would be the two values for X. So right away, then they said X is going to, the line is going to pass through -5 on the X axis. So let me see, 1, 2, 3, 4. So that's, it's going to pass through here. And then it's going to pass through -1. Okay, so we have 3 points so far. These two are your X intercepts. And then here is your vertex. So we have that. So the third thing we could find now is your Y-intercept. So Miss Fernanda, how are you going to find the Y-intercept? This is where you're going to let X be
0. Okay.
0. So the Y equals X squared plus 6X plus 5. So if X is equal to 0, what you're going to have now?
Okay, so if X is equal to 0, we're just going to be left with +5.
Oh, you went straight to the point. I wanted you to tell me.
Okay, so I mean 0 squared would be 0. And then 6 times open bracket 0 close bracket plus 5.
Okay, so that's Y equals 0 plus 0 plus 5. Y equals 5. Okay, so it's going to pass through the X axis, the Y axis at 5. So that would be right here. Okay, so we have 1, 2, 3, 4 points. Now, this is not the most accurate way to do the parabola, but it gives you a sense of how the parabola should look. You already know it should open upwards. So you could join them, but like I said, when you're doing a parabola, you're not going to use a ruler. You're going to try to do freehand, a smooth curve. So you join them as best you can. And try to make sure you get a rounded edge at the bottom. A rounded, it was off a little bit there at the bottom, but anyway, you continue up. And then, yeah, see if you could make it symmetrical as best as you can. Okay, so that's your parabola. Right, like that. Okay, and so with those 4 points, you can get a picture of what the parabola should look like. And usually with this, we ask you to, okay, they put graph here, but usually some books use the term sketch anytime you're doing this, because you don't have enough points to actually do a more detailed graphing. So oftentimes in some books, they'll use the term sketch, which just indicates that you're given a general look of how the parabola should be. Okay. And so that's it for that portion of the chapter that we're looking at today. All right, so you get a couple of those to do for homework. And so basically you need to determine how the graph should look, find the vertex, which in some cases would be the lowest or the highest point. Then you find your X-intercepts, if there are any. If there are no X-intercepts, then you know, we wouldn't have enough to do a parabola. But I think in the homework questions you're going to get, you will have X-intercepts. And then after that, you find your Y-intercept, and then you use those points to sketch the graph. Okay, so by now you should have received your test that you did last, test 4. Now, I don't know if I need to go through it. I think let me double check here. I'm going to look at the papers. Okay, yeah, I probably need to look at, okay. Okay, I want to just look at it to see where errors were made. So for that test, question number 1B, I think a couple of you forgot that when you divide by a negative, your sign should change. So I think a couple of you got 2 points instead of the full 3 for number 1B. Number 1B is actually worth 3 points. But if you didn't change the orientation of the sign, because that 5 became negative 5x, so when you have to divide by a negative, it causes the sign, the order of the sign to reverse its order. So instead of less than or equal to, that should become greater than or equal to. Okay, and then I think one person made a mistake with the graphing of it. Yeah, okay. Let me see, what else was a problem here? Okay. All right, now for 1D, your graph should be arranged. So it should go from negative 0.75 to positive 1. So you shouldn't have an arrow just pointing to one direction. It should be a range, and the negative 0.75 should not be shaded, but the 1 should be shaded. And there's no arrow for that one because it's a specific range from negative 0.75 to 1. Let me see here. For question 2, I think one person, well, maybe you have to be careful with the signs. Okay, so for question number 2A, it was A plus 9 times A minus 5. You have to be careful with the signs when you are doing that one. Negative times negative is positive, and negative times positive is negative. So the answer for question 2A should be A squared plus 4A minus 45. Positive 9 times negative 5 is a negative 45. And then when you multiply 9 times A, you get positive 9A. A times minus 5 is minus 5A. 9A plus minus 5A gives you 4A in the middle. So that should be A squared plus 4A minus 45. For B, again, be careful with the signs. The answer for that one should be 12y squared minus 13y minus 14. Okay, I think, let me see, everybody got number 3. Let me double check. Number 3. I think so. I'll make out this one. Okay. Okay. Question 4. Okay. Yeah. Okay. All right. So now I sent you a. I think I sent this stuff that for homework and the PowerPoint presentation. I also sent you a practice test. The test, you have a test next week, Saturday, which you have to go into the office to sit. I'm giving you a practice. This is a past test that is set up the same as the test that you're going to do on Saturday. So if you want to do well on the test Saturday, you're going to do this test that I sent as a practice and send it to me by Tuesday evening. Now, when you take a picture of the test and I try to mark it, it comes out very dark. So that's why I prefer if you could print it, then scan it, and send it to me. But if you take a picture, for some reason it's coming out very dark, And so if I mark it and send it back to you, you might not be able to see much of what I mark on it. So I prefer if you could scan it to send it back. And if you send it by Tuesday, I want to be able to mark it and put in the corrections so you could see what errors you're making. And if you have any questions about it, then you have some time to get it cleared up before the test on Saturday. All right. So if you follow the plan, then you should be able to do well on the test, because there's no makeup test for that one on Saturday. So that's why I'm giving you this ahead of time so you could prepare yourself and clear up any misunderstandings you may have, because the test is going to follow the same pattern. So I just want you to have a kind of head start, see what areas you may need to brush up on. So Saturday is the test. And then the Saturday after that is our last class, which would be, I think that's the 30th of April. Okay, so we are almost to the end. And what I'm going to do for that last class on Saturday, the same way I'm giving you this practice test for this Saturday, I'm going to be doing another practice test again in preparation for the final exam. You don't want to miss the last class, because that is the class where we're going to go through practice past exam, final exam, so you can get a sense of how the paper is structured and what type of questions you will be expected to answer. We're not going to answer cover every single thing. We're not going to examine you on every single thing we covered. So I just want you to focus on the main things so you can prepare yourself accordingly. And then of course I'll give you a revision topic list. But the main thing is to get that practice past exam. Now that last class, I'm not going to be recording it, and I'm not going to be sending you I'm not going to be doing a PowerPoint presentation for the last class. So you have to attend to get the benefit of that revision in preparation for the exam. Okay, so your homework is here. So you have a few questions from page 405 from section 7.3. And then we have a few questions, 3 questions from 443, 7.6, where you have to draw the parabola using the intercepts, etc. And then the answers are here. And that's basically it for today's lesson. I don't know if you have any questions or any concerns. You all saw the email I sent with the practice? Hello, anybody there? Miss Nan, Miss La Rochelle, Miss Fernanda?
No questions.
I don't see the practice yet.
You didn't see the email I sent?
Not with the practice. I see the PowerPoint and the results, but I don't see the practice email.
I thought the three of them should be on the same email.
Oh,
Anyway,
and I see it. I had to slide over.
Okay, all right. Okay, so if there are no questions, then Saturday coming is your second midterm. So you go to the office for that. And please finish that practice and get it to me by Tuesday. So I have some time to go through it and let you know of any concerns or if any corrections so that you could be ready for Saturday. All right, if there are no questions, have a good week.
I wasn't able to locate last class recording on YouTube. Do you know if they posted it as yet?
I am not sure. You'd have to check with Miguel on that. He's the one who is responsible for that. I know I did record it, but he's the one who did the posting. So you'd have to check with him on that.
All right.
Okay, so that's it for now then. I'll see you not this Saturday, but the following Saturday. please make sure you are able to attend. Okay, you don't want to spend this 14 weeks and not get the final lesson. Okay, though. So we'll see you then. Bye bye.